Friends, good afternoon everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel, Dr.Satendra Kumar. Dear friends, if you want this type of videos related to mathematics for higher level, then you need to subscribe, share and like my videos and my channel. Today we will discuss inner product space. Now there are some theorems proof here. Now theorem number first. Theorem first. Let VF is an inner product space and U, V belong to VF, then alpha into U plus beta into V inner product with alpha U plus beta V equal alpha bar U inner product with U plus alpha beta bar U inner product V plus alpha bar beta V inner product U plus beta bar V inner product with V. Okay, we have alpha beta element of field. Now proof here. We take alpha into U plus beta into V inner product with alpha U plus beta V is equal to alpha into U inner product with alpha U plus beta V plus beta into V inner product with alpha U plus beta V. Okay. Now by conjugate symmetry, alpha into U plus beta into V inner product with U whole conjugate plus beta into alpha into U plus beta into V inner product with V whole conjugate. This is equal to alpha into alpha bar U inner product with U whole conjugate plus alpha into beta bar V inner product with U whole conjugate plus beta into alpha bar U inner product with V whole conjugate plus beta into beta bar V inner product with V whole conjugate. Okay. Now this is equal to, we can write alpha into alpha bar U inner product with U, the conjugate of U inner product V is equal to U inner product U plus alpha into beta bar U inner product with V plus beta into alpha bar V inner product with U plus beta into beta bar V inner product with V. Okay student. Now next theorem. Theorem number 2. Let VF is an inner product space and alpha comma beta belongs to F and U comma V comma W belongs to VF, then U inner product alpha into V plus beta into W equal alpha bar into U inner product V plus beta bar U inner product W, where alpha comma beta belongs to F. Now prove here. Taking U inner product alpha into V plus beta into W equal to, by symmetric conjugate, alpha into V plus beta into W, inner product with U, this is equal to whole conjugate alpha bar into V inner product U whole conjugate plus beta bar W U inner product both whole conjugate. Now we can write alpha का whole conjugate into U inner product with V plus beta bar U inner product with W, not conjugate. Okay, this is not conjugate. This is the proof. Now next theorem. This is very important, very most important theorem. This is known as Cauchy, C-A-U-C-H-Y, Cauchy-Schwarz, S-C-H-W-A-R-Z apostrophe S, Cauchy-Schwarz inequality. This is most important statement. Let VF is an inner product space and U comma V belongs to VF, then U inner product with V whole modulus always lesser equal U norm into V norm. Proof. Now repeat the statement of Cauchy-Schwarz inequality. Statement is, let VF is an inner product space and UV are two elements of VF, then inner product of UV modulus always lesser equal to U in norm into V norm. Proof. If U equal to 0 and V equal to 0, that is both elements are 0, then the given inequality, is valid. Okay. But now in case of both are not equal, U is not equal to 0 and V is not equal to 0. In this case, we derive the inequality. Let us consider a new vector W equal to V minus V inner product U upon UK norm whole square into U. Now take U inner product or W inner product with W equal to, we put the value of W, V minus V inner product U into U vector upon U के नॉर्म का होल स्क्वायर इनर प्रोडक्ट V माइनस V U इनर प्रोडक्ट इंटू U अपॉन U नॉर्म स्क्वायर. Now we can write inner product this V inner product of V minus V inner product of U into U upon U norm square minus V inner product U upon U norm whole square now U inner product with V minus V inner product U into U upon U norm whole square. Okay, there are, we get two element here. Now again inner product. Now V inner product V minus V inner product U upon norm of U square. Now V inner product with U. Okay, minus, now we can take U here again, V inner product with V minus, this is the outside, and by conjugate symmetry according to the inner product, according to the theorem number first. Now inner product of V minus U, inner product of V and U का whole conjugate, then we get V inner product with U. Similarly here V inner product U as it upon U norm square. Now U inner product with V minus minus plus V inner product U upon U norm whole square as it. Now V inner product U whole conjugate upon U norm square as it. Now U inner product with U, U inner product with U. Okay, now we can write V norm whole square minus V inner product U whole conjugate upon U norm square as it, V inner product with U minus V inner product U into U inner product with V upon U norm whole square as it. Okay, now plus V inner product U into U inner product V inner product U whole conjugate upon norm of U square into norm of U square, or this is the value of norm of U square. This cancel by this. Okay, now last term is cancelled by second term. This is the whole term is cancelled by remaining term. Then we get norm of V square minus V inner product U into U inner product with V upon U norm whole square. Okay, Now we can repeat here V norm whole square minus V inner U inner product V, and this is the U inner product V का whole conjugate upon U norm square. Okay, this is equal to V norm square minus UV inner product modulus whole square upon UK norm का whole square. Okay, but W inner product W is equal to W norm का whole square, always greater than 0. Okay student, V norm whole square minus UV inner product modulus whole square upon norm of U square as it always greater or equal to 0 imply that norm of V square into norm of U square always greater or equal UV inner product modulus whole square imply that U inner product V modulus always lesser or equal to norm of U into norm of V. This is the complete proof. Okay. Now next theorem. Triangle inequality. This is the triangle inequality. This is the most important statement. If VF is an inner product space and U comma V belongs to VF, U comma V belongs to VF, then U plus V whole norm always lesser norm of U plus norm of V. Okay. Now proof. Taking U plus V norm whole square is equal to U plus V inner product with U plus V. This is equal to U inner product U plus V plus V inner product U plus V. This is equal to U inner product with U plus U inner product with V plus V inner product with U plus V inner product of V. This is equal to U norm square plus U inner product with V plus U inner product with V a whole conjugate plus V norm square. We know that the inner product of UV plus whole conjugate of inner product of UV, then we get U norm whole square as it plus this is equal to 2 times of real of inner product of UV plus norm of V square as it okay. this is equal to u norm square plus 2 modulus of inner product of uv. This is always greater than plus v norm whole square as it. Always lesser equal to u norm plus v norm whole square. Okay, that is u plus v norm का whole square always lesser equal to u norm plus v norm का whole square. Now taking square root, u norm plus v norm always lesser equal norm of u plus norm of v. This is the triangle inequality. Okay.